Alright, so the electrical part of the system is louder than the motors and mechanical part. As you can tell, there's really no noise coming from that. It's all coming from right here. Been running for over 10 minutes. We still have 23.2 volts on the battery bank. It hasn't moved. We are running, everything is running, that's moving and running is on the system, is running from the system. We've got about 6 amps consumption on this motor, but we're getting that back out from here. I've got it running at 24.9, about 25 volts there. And like I said, this is 23.2. So that's the battery bank. I've got my charge circuit run through here. A couple of diodes separating it there, and a diode on the cap here. And it runs itself. It's been running itself for 10-12 minutes now. And yeah, we'll put a load on it now. So finished getting the wire and everything here, and let the machine run, and let you sit here and watch it. That's about 13 minutes now, and we're still at 23.2. And that's, like I said, that's the battery bank. There's the negative terminal and the positive terminal going to this. Now, I've got the negative terminal here going to the frame ground and one side of the output. So it's not showing both voltages coming from the motors. Now, I've programmed this Arduino to run these relays at a certain frequency. So there's, the higher the frequency, the less current consumption. The higher the voltage, the less resistance. So, like I said, we'll continue getting this little plug here and wiring it up. But as you can see, it's doing exactly what it's supposed to do.
And the good thing is we're not breaking the laws of physics. We're just kind of skirting around the edges.
Right.
Bending them a little bit.
Pretty much just manipulating the laws of physics. Because I'm using the same energy that the system is using and is powering. The only thing is I'm using a higher voltage on the output, so there's less consumption. We're at, say, about 14.5 minutes right now, and it still hasn't moved. Oh, it's flickering back and forth now. There we go. Almost a milliamp power consumption. We're gonna see what all power draw, how low we can get it. See if we can shut her down. Which I'm sure we can, considering it's a very small unit.
And the reasons what we got.
Right, the smallest one we have here. I'll take you here in just a second and show you part of the large unit. We are in a holdup right now. We need motors, and we are $750 short of getting these motors in. I'll show you the well, look, no, look, it turned off. This turns off after 10 minutes, and I've already reset it once. So that's 20 minutes, and I've got the consumption with the power, the voltage drop, and I've got the consumption down to 100 milliamps. So, and now that's, you know, we don't have this out. It's not even hooked up yet. And we don't have the other power inverter on here yet either. We're getting ready to wire the receptacles in. And as long as this number stays where it's at, we can pull energy from the system. So there you have it. Let's go look at the new model. This is 30,000 watts for 5 seconds, and then it's 20,000 watts continuous. We've got 2 of these. One is at the machine shop right now getting a plate fitted and the motor mounted to the front of the generator. All of the wiring is on the inside of this box here. I don't have my drill handy, or I'd show you. There's just 3 connections in here, and then you've got the AVR, the automatic voltage regulator, sitting on the side of the box there. But there you have it. Wanted to give you guys a nice little update. As you can tell, well, like I said, the controller is louder than the motor, and we've got to get a stronger relay pack, because this one's getting warm, and we don't want anything getting warm, pushing the limits of the current on this one. So we've got we're going to get another one ordered, which will keep that'll lower the energy consumption of the machine itself as well. And yeah, here, sit back and watch for a second, and we're going to wire this together. Plug it up. Yeah. Sprinklers.
Yours? Right there. No, the chair.
Well, I cut that a little long.
Not better.
And there's 2. And we have had a 100 milliamp consumption. It finally, the voltage dropped down just a little bit. 23.1. Yeah. But like I said, as long as this stays 24.9. We're good. And we're another 10 minutes. That's 20 minutes. And we got it to another 100 milliamp voltage drop. So 23.1. I'd say we're doing pretty good. Got the connectors on here. Let's put this on there and we're good. Give me a second. Where the plug? Oh. There we go. And the other one. Oops. There. 23.1, still on the voltage meter. Yeah. And like I said, the motor consumption is a little under 6 amps. So we're using energy here. But you notice the battery bank is not seeing any problems. Alright, now we have all the plug-ins live. Got to get a screw put in the on and off switch here. All our receptacles are live now, so let's get a light going. What we got in this one? 60 watts. That's not too big, but that'll give us a. You won't hear any draw or anything, so.
There's a 5 watt over there.
All right. Now, in order to do that, we've got to use 100 milliamps of power. Lights on.
Even.
23 even. Yep. Lights off. Back to 23.1.
So the other one.
Yep. Let's see the other one.
Battery still making power.
Light on.
Got 20%.
It dropped to 100 milliamps. But as long as it stays 24.8, 24.9, we're good. It's going to stay right there. And we got 23 there. 24.8 going back into it. Yeah, I'll just plug that in.
Yeah.
Yep. Now we have an extra 60 watts consumption.
Yeah, we can hook another one up. Got 75 more watts over there.
Yep.
Yeah, I'll drag it out.
Yeah, we plug that one's got a good power. Yeah. We are, how much power did we use yet? Pretty much nothing. Pretty much nothing. We're at 24 minutes into running the test, and yeah, the machine is doing its job, that's for sure.
Alright, you ready?
Yep. Alright.
Here's another 75 water.
Another light. No noise difference whatsoever. Alright. Now what I'm going to do is I'm going to unplug those lights and let you hear how big of a draw this is on this motor. Now both lights are plugged up to the receptacle.
24.8, 24.9,
So
9.
it went off because it's, yeah, after so long of the meter just sitting there, you've got to turn it back on. Yeah.
23.1.
Yeah, it's charging back up because I turned the light off for a second. Yeah, 25. Steadily sitting there. All right, now no change in the motor speed. I'm plugging both lights up now. That's 60 watts there, and what's this
75.
one? It's 72. 72.
72.
Close.
We need another metal 72. Sound the same. Didn't hurt it none. Dropped to 24.
I can't hear any difference whatsoever in the motor. Yep.
Loops at 22.9 now.
Yep, we lost another 100 milliamps to run 72 watts. 100 milliamps equals 72 watts is what that works out. Yep. With the extra light on there, yeah.
We're still at 24.8.
Yeah, as long as the input power still stays up there, above where our battery is at, we're good. Let's see, I can take, as soon as I unplug this, our battery,
Goes back 24.9.
yeah, it'll go right back up. See, we're 17 minutes into the video. The machine's still pulling 6 amps on the motor. And then half an amp on the controller and everything. Yep.
So basically, in layman's terms, we're using 23 and putting 24.9 back in.
Yep, we're using 23, but putting 24.9 back into it.
And we've got, what, 150 watt up? No, about 125 watt. For the light bulb, we're losing
Let's see,
nothing.
60 and 70. It's 132. It's 132 watts.
Yeah.
132 watts, and we're dropping 100 milliamps. And the machine ain't gonna stop running.
Terrible.
Yeah, terrible efficiency. All right, brother. Yep, I gotta get some stuff backed up for the trip. So, all right, this like I said, this model will be available real soon.
Get your pre-order ad now.
Yeah, we're fixing to start taking orders right now.
Company
Easy Power for You.com. Yep, and Energy Buoys have created forces or joined forces. So we've got the 3,000 watt system. We've got the 4,500 watt system. We've got more extra parts. We've run so many tests and so many different machines and stuff that we have stuff that's still not put together. We're still working on. But yeah, this one's we've got 3 different models pretty much, 3,000, 5,000, and the big one that'll be finished in about 2.5 weeks, and it's going to put out 20,000 continuous.
20 continuous.
Yep. Let's see, even pausing and walking back here, everything. Go look at we still got the machine running over there with all the lights on.
Yeah.
Yeah. Well, I wasn't thinking. Yeah. It doesn't. Yeah. Oh, 100 milliamps there. So we're at 30 minutes. 100 milliamps. Well, okay. charge it back up then. And there we go. We'll go back to 24.9 and let the system charge itself back up for just a minute. And we can use more power, all we want. It's been going for 30 minutes, so yep, I'd say that's good enough. Well, yeah, every 10 minutes this goes off. You see, I did it at 10 minutes, so yeah, 20-minute video plus the 10 minutes we had it running before time, probably 15 minutes before time. Yep, 23.0. It finally, battery level finally leveled out, and so that's what we got, 23, and this one will stay 24.8, 24.9. And this thing just, yeah, it's just gonna go forever. So no point in turning it off. Yeah. Well, there you guys have it. Nice little update, and I'm gonna go ahead and we'll put some web addresses here for let's see, energy buoys, easypowerforyou.com, and PayPal. All right, love you guys. Don't forget to like, share the videos. You know, I've open sourced everything that I've got and everything that I've done, and this is an older model of mine, but I mean, there you have it. You know, there you have it.